Good day. Uh, as you can see, the subject for this section is mathematics, and we're treating trigonometry. So, what's trigonometry? Trigonometry is simply the study of triangles in relation to their sides and angles. It is simply the study of triangles in relation to their sides and angles. So, let's draw the diagram. Let's construct the diagram of a triangle. So, where are the sides of these triangles? If this triangle is labeled A, B, and C. In mathematics, when a triangle is labeled like this, how do we get the labeled sides? What do? We notice that we have A here, the capital A. Then this side is definitely going to be the small a, as well as this, which is the capital B. This side is going to be the small b. And for this as well, the size is going to be small c. So you should understand that. So where are the sides of the triangle? These are the sides of the triangle: the A, B, and C. The small a and b. And where are the angles? The angles are the large A, C, and B, which are these are the angles. Your why these are the sides. These are the sides. So we should know that these are the sides of a triangle. So now we should also know that. Okay, let me quickly do this. Okay, now you should know that where theta is facing is opposite, is known as what? The opposite. So this is the angle theta. Where it is facing, it's facing this direction, is known as what? The opposite. So it implies that this direction here is known as the opposite. It is also known as in trigonometry. So where theta is facing is known as the opposite. Maybe I should write it down here. Opposite is known as the opposite. Where the theta is facing is known as the opposite here. Where right angle is facing is the hypotenuse. Where is the right angle? Here is the right angle, because in trigonometry we are working with right angles, because this is an angle of 90 degrees. So where this angle is facing is known as the hypotenuse, and it's facing here, so it's known as the hypotenuse. Let me quickly do that here. The hypotenuse. Okay, maybe I should increase it. It's known as the hypotenuse here. So here is the hypotenuse. So why the remaining side is the adjacent? Why the remaining side is the adjacent? So where is the remaining side? You should know that, because here is the remaining side. B is known as the adjacent. The adjacent. Okay, now that's good. So we can simply say this for this part here, for BC is equal to the hypotenuse, then BC is equal to, okay, maybe I should construct it like this. So for BC is equal to the hypotenuse. BC is equal to the hypotenuse. What do we have again? Okay, for BA, for the side BA is equal to, BC is equal to the hypotenuse. BC is equal to the opposite, while BA here is the hypotenuse. While AC here is the adjacent. AC is the adjacent. So BC is the hypotenuse, BC is the opposite, BA is the hypotenuse, while AC is the adjacent. It doesn't necessarily mean the diagram should be labeled like this. any of the English alphabet letters could be used. So diagrammatically we have this, the opposite, hypotenuse and adjacent here. So now diagrammatically we have this. So there are three basic trig ratios. There are three basic trig trig ratios. There are three basic trig ratios. What are they? We have the sine, we have the cosine, and we have the tangent. So we have the sine, the cosine, and the tangent. So those are the three basic trig ratios we have. So, and they are also abbreviated in this form. They are shortened in this form. Sine, for those of us that have encountered the topic like this before, you notice you see something like this, cos and tan. So how do we work with it? So there is also is an acronym, or there is a statement that is used to define these trig ratios. There is a statement that is used to define these trig ratios. We should know that there is a statement that is used to define these trig ratios. So what is the statement? Guess what? There is a statement that is used to define these trig ratios, the sine, cosine, and tangent, because they all have definitions. So what's the statement? The statement is known as the SOHCAHTOA. Please repeat that. The SOHCAHTOA. The SOHCAHTOA is the statement we use to define the trig ratios. So now let's begin. Applying let me erase this. So now, SOHCAHTOA works with sin theta, the car works with cos theta, the toa works with tan theta. Don't forget here the three trigonometric ratios: sine, cos, and tangent. So works with sin theta, car works with cos theta, and toa works with tan theta. So I'm sorry I couldn't get theta on my keyboard, so that's the reason I'm using 0. Maybe I should distinguish it by doing this. I'm very sorry for that. So now what do we do now? So we should also not forget about this triangle, about the diagrammatic representation of this. We should also not forget that here is the hypotenuse, and the side that faces the angle is the opposite. Can you see it here? While the remaining side is the adjacent. So how do we get sin theta? What's the definition of sin theta? I told you sine works with so let's come here now. We have SOH. So the O here stands for opposite, while the H here stands for hypotenuse. So let's do that now. The O here stands for opposite, while the H here stands for hypotenuse, and the H here stands for hypotenuse. The H here stands for hypotenuse, which implies that which implies that so is also equal to sin theta. Then sin theta is equal to opposite over hypotenuse. Sin theta is equal to opposite over hypotenuse. Can you see I've been able to derive it? Since so works with sin theta, then O here stands for opposite, H stands for hypotenuse, then sin theta is equal to opposite over hypotenuse. So now let's work with car. Let me erase this. Yes, erase this. Okay, and erase this. So what do you have here? You have car, CAH, car. As car works with cos theta, what do we get? The H here stands for adjacent. You should know this, and the H here stands for hypotenuse. So that is it. It stands for adjacent. The H here stands for hypotenuse, so which is equivalent to cos theta, which implies that cos theta is equal to adjacent over hypotenuse. So, and for 12, you should be able to derive that yourself. And here is it. Let me use this here and this as well. So for tan, what do we have? The for TOA, the O here stands for what? You should know that opposite. Why the A here stands for hypotenuse, adjacent. Sorry. So you should know that tan theta is equal to opposite. Then tan theta is equal to opposite over adjacent. So that's very simple. And those are the three basic trigonometric ratios. That's very simple. So what's next now? We're moving to special angles trigonometric ratios. So what are the special angles trigonometric ratios? I'm not going to tell you, getting that yourself. So the angles you can even derive without the use of the calculator. So when you're giving that in an exam, you don't need to make use of the calculator to get the answer. When you're asked to solve the sine of 30, or you have to determine the value of sine 30, sine 60, sine 45. Those are values you expected to have understood. Those are special angles in trigonometric ratios. So now let's begin with the first one. Let's begin with the angle of the angle of 45. The angle of 45 degrees. The angle of 45 degrees. So to achieve the desired good here, you must allow for the mathematical assumption that follows: a right angled triangle whose theta is 45 degrees with opposite and this sides of unit 1. Then by Pythagoras theorem, the hypotenuse is 2. So there's a derivation for this, but I'm not going to dive into that in order to utilize our time well, so that we won't waste much time. So for this, there's a triangle that is constructed for this angle of 45. You have something like this here. You have this, so you must be memorizing this. You have 45 degrees here, angle of 45. You have 45 degrees here, and we have root 2 here that has been derived already. We have 1 and 1. So can you see it now? So what does this mean? It implies that when we're searching for sine theta, you know, this stands for theta, where theta is 45 degrees here, where theta is equal to 45 degrees, as you can see here. So when you have to determine the value of sine 45, how do we do it? You know, I told you earlier that this place stands, the side facing the angle is the opposite. So here is the opposite. Okay, maybe I should use my guide. So the side facing the angle is the opposite, while the longest side is the hypotenuse. Here is it, and the remaining one is the adjacent. So now what do we do? So how do we get the sine of 45 degrees? How do we get that? Now, so we notice that, as I stated earlier, that the sine works with so, and I've explained earlier that sine theta will then be equal to opposite over hypotenuse. So which implies that here sine 45 will be equal to the opposite, which is 1 over the hypotenuse here, which is 2. That's 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 it. You don't have to spend much time. So how do you work with cos 45? You should be able to determine that. I said earlier that cos works with car 2, and the adjacent. So cos 45 is equal to the adjacent of hypotenuse, which is equal to the adjacent is definitely what for cos 45 1 adjacent, and the hypotenuse is root 2. So that is it, root 2. So for sine, for what again, the remaining cheek ratio, which is tan 45, will give what? So you need to understand that will give tan, and as I stated earlier, that the time works with 2, which is OA, which is the opposite of adjacent, and here is the opposite 1, and the adjacent is 1, so which is equal to 1. So tan 45 degrees is equal to 1. I have been able to derive the angle of 45, the cheek ratios. That's very simple. So let's move to the to another special angle very fast, so you can take a picture of that. So let's move to the angles of 30 degrees and 60 degrees. The angle. So these expressions are very simple. You need to be able to memorize the diagram so that you can derive them when you get to the examination hall. So the angle of 60 degrees and 30 degrees. So there's a mathematical expression for it. So I'm going to move directly to the diagrammatic representation. So how is it done? So let's take a look at this. We have this diagram here, and we have the symbol of the right angled triangle. We have angles because so we have angle 60 degrees here and angle 30 degrees here. Okay, so we have 3 here, so don't be concerned about it. It has been worked out, and we have 1 here. So and we all know that here is the opposite. You have to get that, because no, we now have 2 angles now. We have angles 60 and 30. So what can we do? How do we determine the opposite? Firstly, let's write the hypotenuse. So now there's a particular method we follow. So now, before we determine the opposite, because we don't know the opposite and adjacent, the actual opposite and adjacent now, but now let's begin to solve. So how do we get for sine? Let's begin with the angles of 30 first. For 30, how do we get sine 30? How do we do that? You should be able to do that. No, for sine 30, that shows that we are working with this angle here, and so definitely the angle, the side that faces the angle is 1, which is going to fall. So for the sine, for the 30, for the angle of 30, so here is the opposite. Here is the opposite, which is 1. Can you see that? Opposite, because we have sine as so opposite over hypotenuse. And where is the hypotenuse? Along this side, which is 2. So that's it. Tan 30 is equal to 1 over 2, which is also equal to 0.5. So now for cos 30, will be equal to what? For cos 30, we have the adjacent, which will be root 3, then root 3 over the hypotenuse, which is 2, and we have tan 30, which is equal to, because tan tan 30 is 12 OA. It works with OA. So the opposite is for tan, the opposite for 30 degrees is what? 1, and the adjacent is with 3. With 3. And instead of being able to derive that, that was actually amazing. So now let's work with let's work with the angle of 60 degrees now. Let's work with the angle of 60 degrees now. So angle of 60 degrees. Yeah, so now let's change this to 60 and this to 60 as well. So how do we do that? Now for the angle of 60 degrees, okay, sorry, let me quickly delete this here. Okay, now let's proceed. For the angle of 60 degrees, it's very important to include degrees in your homework, because I'm making use of a computer system. I can't find degrees like that. So well, the angle of 60 degrees here, now here it is, here is the angle, and we said that the angle that faces the side that faces the angle is known as the opposite. So for 60 degrees, here is its opposite, which is with 3, because that is the one that faces the angle with 3. Okay, and okay, that's it. So now for sine 30, for sine 60 right now, what is it? We have so opposite and hypotenuse. For so sine is what? With 3 over hypotenuse, which is with 3 over 2. Cos 60 is definitely going to be 1 over 2, and tan 60, which is with 3 over 1, which is also with 3. Successful. We have been able to derive that successfully. That was very simple. So now what are you going to do now? So now let's solve questions on that right now. So let's solve questions on that right now. So find the values of the unknown size in the diagrams below. So let's work with the first question here. Find the value of the unknown side in the diagram below. Now, where is the unknown side? Okay, the unknown side is x here. So firstly, let's highlight the side. You know that x here, x is going to be the what? Since it's the side that faces the angle, is going to be the opposite. 4 here is the hypotenuse. Okay, 4 is the hypotenuse. So let's work with this, since the only values are needed. So what do we do? Since we know, and here is the angle 45 degrees, since we know that sine 45 is equal to, based on what we did, okay, don't let us apply that yet. We have sine 45 as also so, which is opposite. Okay, let me use the white plane, which is that opposite over hypotenuse. We have sine as this, and sine 45 is opposite over hypotenuse, as you know. So sine 45 here is going to be the x opposite over the hypotenuse, which is 4. So based on what we taught recently, we find out that sine 45 degrees, okay, let me write that here, sine 45 degrees is also, if you can take the video back to this portion I treated it, you find out that 45 degrees is equal to 1 over root 1 over root 2 is equal to 1 over root 2. So figure out that sine 45 degrees is equal to 1 over root 2. So we can actually substitute that value of sine into this here. Since we know that sine 45 here is x over 4, then sine 45 is also 1 over root 2, which is also x over 4. Then what do we do? What's the next thing we do? Let's cross multiply. We have, okay, maybe I think I have to get, we have 4 over 2. Cross multiplication means this times this. 4 is multiplied by 1, and x 4 is multiplied by 1. So let's make it like that. So 4 over root 2, since there's an equal sign here, so it can work like that, is equal to x. So 4 is multiplied by 1 to get that. So what do we do? How do we get the value of x? So we rationalize. So with knowledge of sorts, we'll be able to do that. So what do we do now? Get what? 4 over rationalization here. 4 over root 2 is equal to okay, I think I have to use a yellow color for that. So we have 4 over root 2 in rationalization of sorts. Since I think we haven't treated it in my channel, so you have to follow up right now. So 4 over root 2 will be multiplied by, we are actually doing rationalization right now. So 4 over 2 will be multiplied by its denominator, which is root 2, multiplied up and down like this. Okay, sorry, like this. So what do we get here? Get 4 times root 2, which is what? 4 root 2 over root 2 times root 2, we get root 4. Then 4 root 2 over root 4 will be equal to what? 2. Root 4 will be equal to 2. And we know here we have 2 can 4 can be divided by 2, get 2 here, then remaining will be what? 2 root 2. Therefore x is equal to what? 2 root 2. So x here will be equal to 2 root 2. Simple. Can you have been able to, maybe you have been able to apply the knowledge we just learned. So let's have another question. I'll be rounding off the class. So what's the next question? We have a diagram like this, and we have, okay, maybe I should make use of another angle. We have here like this, we have the angle of 60 degrees here, and 3 here, then Z. We have 2, then Z. So what are you asked to do? Okay, maybe I should change this to y here. Y. So you have to find the value of the unknown side. You have to find the value of the unknown side. So what we do, since we know that y here is the hypotenuse, and 3 here, since it's the angle that faces the since it's the side that faces the angle, is the opposite. And okay, I think that's all. So what do we do? And we have hypotenuse here, we also have opposite here. So in which of our formula do we have hypotenuse and opposite? Let's check it out. We have O and H. Okay, that's definitely so. So therefore we can use sine. So that is where is the, okay, you can, that is you can make use of sine, then sine t times sine 60 will be equal to what? The opposite over hypotenuse. Okay, sorry, over hypotenuse, which should be equal to the opposite will be 3 over hypotenuse. The opposite is 3, hypotenuse is y, and based on what we've done earlier, length that sine 60 is with 3 over 2 with the use of the special angle. With 3, so then 3 over y will also be equal to with 3 over 2. So you should be able to complete this now. Then what do we do? We cross multiply here. What do we do? We cross multiply. So this should be multiplied by this, while this should be multiplied by this. So we have 3 times 2, which is 6, which should be equal to y times 3 will be what? Y with 3. So what's the next thing? We now have to rationalize, but before we do that, you can definitely say y with 3 is also equal to 6. Then y is equal to 6 over with 3. Then now let's rationalize this value based on what we did earlier. Maybe I should erase this. So you have, so yeah, let's continue here. 6 over root 3 is what? 6 over root 3 times what? Multiplied by the denominator with 3 over root 3. What do you get? 6 times root 3 will give us 6 root 3 over root 3 times root 3 with 9. Then what do we do? You can definitely divide. So we have 6 with 3, right? Then it's also equal, 6 with 3 is also 6 times with 3. Okay, before we even do that, so let's take a bit back. Let's erase this, erase this, erase this. So from here, when we rationalize 6 over 3 multiplied by 6 with 3 over 3, you can definitely cut this value here, these values, by saying this cut this. Then, oh sorry, that's not what I intended. You can definitely do this. Sorry. So for that, so let's proceed. Okay, let's proceed. We have 6 to 3 over with 3 times with 3, we get what? With 9. 3 times 3, which is 9. Then what do we do? 6 with 3 over with 9 gives us 3. Then this can be divided by this. Then 3 and 6, we get 2. We get 2 here with 3. Absolutely, we definitely gotten our answer. So thank you very much for watching. In our next class, in our next session, we'll be looking at advanced methods, advanced ways. We're getting into the trigonometry ratios of angles between 0 degrees and 360 degrees. So please like, share, and subscribe to this channel. So ensure you solve more questions yourself, and you can definitely share your answers to these email addresses here. Then you actually get response. So ensure you solve more questions. Thanks for watching. Thank you very much.